Now, I realize that I have not created a cam for Fretboards video yet, so those of you who would really like to see that, don't worry, I will get to it, I promise.
2,000 years later.
Hey everybody, this is Austin and welcome back to the channel. That's right, as you just saw, today we are going in depth with how to program the cam for Fretboards in Fusion 360. Now, about a year ago, I was making cam tutorials on just about every part of guitar making, yet somehow I completely forgot to do one for Fretboards, and many of the viewers have not let me forget about that since. So I thought it was about time to honor that promise and go ahead and take care of that. Now, this is 4th of July weekend, so if you do hear any fireworks going off outside my house, that is why. But let's not waste any more time and dig right in. All right, so quick disclaimer. Methods I'm going to show you should apply to just about any design. However, fretboards can get much more difficult when you get into more elaborate binding and inlay work. So if you have a really complicated design, you may have to branch out from my method a little bit and get a little bit more creative with your toolpaths, but this video should get you 90% of the way there. So let's go ahead and get started. Okay, so first things first, we always want to create a new setup. So this is where we set up our stock, our work coordinate system, our model, etc. So I'm going to go ahead and set up my work coordinate system, and I want to be able to select my X and Y axes. Now, sometimes when you click that, the origin point here will show up, which is really helpful in fretboards. But if that doesn't show up, go ahead and open up your model tree right here, and you can show origin like that. And that will help because what happens with fretboards, for example, is you want your X and Y axes to be going, vertical or horizontal to the machine. You don't want them to be going like tapered like this unless you deliberately set it up that way. So what we're going to do is we're going to select our Y axis, and I'm going to hide the body, and I want the Y axis to be going in this direction. And I want my X axis to be going in this direction. Now let's bring the body back. Okay, so now we have them going in the correct direction, but our point is at the wrong location. So let's say stock point, I want to move it to over here. And we have our Y going in the right direction, X is going correct, but Z is wrong. We want to flip our X and Z here. So we're going to say flip X. That rotated it from this side of the center point to this side. And now everything is in the correct location. So let's just go ahead and check. Yes, our model is the fretboard that's already selected by default. If it wasn't, you just go ahead and click that, click on your fretboard model, and you're good to go. Now in our stock, right now it's set to relative size box. So let's see what it's trying to apply. Okay, so it's trying to apply a little bit on the sides and the top, which is okay. I'm going to give it a little bit extra. So let's do side offset of 0.25 inches, like that. And then we will say our top offset is 0.1 inches. Now you will need to set this based on whatever stock size you're going to be using. So if you have the actual dimensions of your stock, go ahead and say fixed size box, type in those dimensions, and then you'll be good. If you just want to do this for reference and then later buy or mill a stock to match this, then you can go ahead and use relative size box. Let's go ahead and hit OK, and we are done. Now, I went ahead and left material on the top, even though I didn't do that in my Mare build, because you can go ahead and do a facing operation right here in order to bring this to the correct thickness. And I wanted to go ahead and do that in this video. So if you're using stock that is a little too thick for the fretboard that you're using, you'll want to go ahead and do a facing operation. If you've already milled it down to the correct thickness for your fretboard, you can actually skip this step. But I wanted to show this for those of you who are working with stock that might be a little bit too thick. Okay, so let's go ahead and go to 2D face. And we're going to face off all of that material down to the top of this curve of the fretboard. So let's select our tool. And I'm going to use just a 1/4 inch flat end mill. You can use whatever size end mill you want. And I'm not going to worry about the feeds and speeds right now because this is just for simulation for this video, but you can put in whatever feeds and speeds you need for your machine. And then geometry, facing is usually already selected for you basically because it just uses the stock contours and then faces it down to the depth, which is the model top usually. And then in this case, that's correct. So we don't need to change anything here. And then in passes, we just want to know what is the pass direction and what do we want to use multiple depths. So I'm going to go ahead and hit OK right now just to see what it's going to do. It's going to mill off all the top of the stock, but we've got a pretty large step over here. So let's simulate this really quickly. And look at it from the side view. Okay, yeah, so we're doing a full step over at 1/8 of an inch deep, or roughly 1/8 of an inch deep. So let's go ahead and change that step over to be a little bit smaller so we're not overloading our tool. And let's actually go ahead and do multiple depths just to give ourselves a little bit of breathing room. So I'm going to come back to the face operation and hit edit. Come over to passes, and we're going to say step over. I'm going to do this to just under half my bit depth, or bit diameter, I mean. So I'm going to do 0.1 inches, because it's a 0.25 bit. And then multiple depths, I'm going to say 0.0625, which is roughly half of the material that I left on top. So we'll do it in basically 2 passes. We should be okay there. And I'm going to go both ways. I don't need to do climb or conventional. Hit OK. Should give me 2 layers of toolpaths at roughly half the bit diameter. So let's go ahead and simulate this real quick, just to prove that out. Okay, yep, we're good. And let's turn off transparency here. We're going to face off the entire top with 1 layer. Come back, do the second layer, and then we are now flush with the top of our model. Now, one thing we didn't do, which I should have done, is actually have a little bit of stock to leave, because we're going to come back in and do a parallel toolpath later to go ahead and clean up the radius. And we want to have a little bit of extra material on top. So let's change that real quick. Come back to the facing operation, edit, passes, and in stock to leave, we want axial stock to leave of, I'm going to leave 20 thousandths of an inch. So 0.020 inches. And that should be good. That's about 0.6 millimeters. I think it's a little bit under that. Hit OK. Let's simulate this one more time and then we'll move on. Okay, we got layer 1 and then layer 2. And let's do transparency and let's look at it from the side. Yes, we do have a little bit of extra material left on top that we can use to when we do the parallel toolpath. So this operation is done and we're good to move on. Okay, so now that the facing op is done, now we can move on to the rest of the toolpaths. Now we can pretty much break down the entire cam strategies for a fretboard into about 4 categories. There might be 1 or 2 more than that depending on the design, but really there's about 4 that we care about. The first one is the outer contour. We'll just cut the profile of the fretboard. The second one is the radius of the fretboard, usually a parallel toolpath. So we actually establish the radius. There is the inlay pockets, so that way we can glue in our inlays. And then there is the fret slots. Now, it's pretty much a choose your own adventure on how you'd like to structure these toolpaths. There's really no, or not necessarily structure, but order these toolpaths, because there's really no right way to do this or wrong way to do this. It kind of just depends on the workflow you'd like to deploy while you're at the machine. Now, some people might like to go ahead and cut their inlay pockets next and glue those in, and then maybe do their radius and cut the contour final and do their fret slots, etc. Or do it all in reverse. It just depends. So what I'm going to do is I'm going to show you the way that I think is the most effective way of doing this. But again, choose your own adventure. Okay, so I'm going to jump right into doing the inlays, because right now we've got a little bit of stock left on top of our model and it's flat on top, which is great. So we are at a safe point where I can install and cut off any of the excess of the inlays, let's say with a saw or anything, without any risk of damaging the fretboard. So I think right now is a great time to go ahead and cut the inlays, glue them in, and then complete the rest of the fretboard. So there's a couple different ways to do this. Now, in this case, because we've got circular features, we could use a boring operation like right here. Although when you do boring operations, you kind of need to have a end mill that is at least half the diameter of that hole. Otherwise, you'll be left with some material in the middle. And so then you have to do multiple passes of that bore. So if you don't want to do that, so for example, right here, this is a 1 millimeter gap right here for some 1 millimeter tubing, for example. And so I might want to do the entire thing with a 1 millimeter bit. And so I wouldn't really want to do a boring operation in this case with a 1 millimeter bit. So I think what's best to do is to go ahead and do a 2D pocket with multiple depths with a 1 millimeter end mill, so I can take care of all of these guys, and then come in here and do a contouring operation to clean this one up while we have the same tool installed in the end mill. So let's go ahead and do a 2D pocket. And we're going to select our tool to be a 1 millimeter end mill. Now I have this set up in Imperial, so it's 0.03937. Hit OK. And geometry, we're going to hit all of these faces. And we're going to skip that one for now. Come hit all of these. One more. Okay, there we go. And then in the heights tab, we want to go to the selected contours in case there's any difference in the height of these holes. And then the top height, let's go from model top, because right now it's thinking from the stock, and the stock is quite a bit taller than the model here. So let's not start our cut there. Let's start it at model top. And we did leave a little bit of extra material on top, so let's add that material to this. So let's add 20 thou on top of that, and then come over to passes, and let's set some stock to leave because we want to dial in the fit of our inlays. And so I'm going to leave 0 axial, so we're going to cut all the way down to the bottom surface, but we're going to leave a little bit of it radially. And so I'm going to leave 10 thou, radial stock to leave, and then we can come back in and clean that up with a contour operation and really dial in the fit of our inlays. So, and then I'm going to do multiple depths. And I'm going to say we don't want our depth of cut to be at least not greater than the diameter of our end mill. I would actually recommend going smaller than that. So I think what we're going to do is we're going to do a maximum roughing step down of 10 thou, which is roughly a third of the end mill's diameter. And we'll just leave the rest of that as B. And then maximum step over, let's do the same thing. Let's do 10 thou. Hit OK, and let's check that real quick. Okay, and let's simulate this. Because we need these end mills, even though it looks big here, these end mills are extremely tiny and they're very fragile. So you want to be very cautious with them. Okay, but let's look at this from the top real quick. And yes, we do have some of that stock to leave. So let's just finish this simulation, make sure we don't get any errors or anything. Okay, that's looking pretty good to me. So now what we want to do is we want to add in a contour operation, but we want to maintain all of our selections and everything like that. So we can right click this pocket operation and say create derived operation. And we can go 2D milling and contour. And what that does is it's going to create a new operation with all the same selections and everything. The only difference is it's changing the tool path. And so you can see here, it already has everything selected for me. And multiple depths is already selected. Now in this case, we probably don't need it anymore. And stock to leave. This is where we can now adjust the radial stock to leave. So we left 10 thou before. So let's go like 5 thou here. And let's go ahead and simulate this real quick. Oh, it's starting on over here. Okay. Now this is actually ordered by area, it looks like. So I need to actually undo that because we want it to cut a single hole at once. So one thing we could do here is we could try this option called preserve order. So it says when selected, the chain's features are machined in the order that they were selected. And when unselected, the program optimizes the cut order. So let's go ahead and check that real quick and see if it machines all of that in one go. So simulate. And yes, it is now starting with this one, taking 5 thou off and going to the next one, cutting 5 thou off. Okay, so that was a really easy way to fix the order in which this was cutting, so I wasn't spending most of my time in the air cutting nothing, bouncing between all of these. So why did I do that? Well, other than the obvious of we want to dial in the fit, by saving a separate operation like this, we can easily repost the program, throw it on the machine, use the same XY coordinate system, and then just cut a new one. And then take a little bit more off and cut a new one. Take a little bit more off until you get the perfect fit. Then you would glue in your inlays, saw them off, and then we can keep going with the rest of the toolpaths. Okay, and then we have that one inlay here that we need to do a different type of toolpath on. So I'm actually going to go ahead and create another derived operation from this one of 2D contour, 2D milling, and we're also going to do a 2D contour on this one, but we're going to unselect all of these features, and we're going to select this feature right here. And we might actually be able to do both. Let's just do one for now. And then the bottom height is selected contours. Yep. Then model top plus 20 thou. Perfect. And we do have that one selected. I need to unselect that. There we go. And then passes, we want to do basically the same thing, but in this case, because this is a 1mm end mill and a 1mm slot, I'm actually just going to uncheck stock to leave and cut it nominal. Now, what can happen is if we cut it nominally and the tube doesn't fit, then I can come back into this operation, check stock to leave, and create some, let's say, some negative stock to leave. So I could say take out an extra 5 thou, repost the program, and it will widen that hole by a little bit. Now, if you find that the inner diameter, for example, is a little bit too large, then I could also come in here and change this selection to here, and then also take a negative, 2, 3, 5 thou, whatever you need, and you can adjust the fit of that until that fits dead on, and you can glue everything in, and you're good to go. So let's go ahead and do this one right here at nominal, and with all the same settings, let's hit OK. Now in this case, we actually want to do some multiple depths because right now it's going to plunge to the bottom and we have a really tiny end mill. So we're going to go back to edit and go to multiple depths, and we'll take 10 thou like we did before, which is roughly a third or so of the end mill size. Hit OK. And let's simulate that real quick. Just that one operation. Okay, now something it's doing right here is it has a lead in. So we don't want it to have a lead in because it's taking a little chip out of that inner material. So let's back out, hit edit, come over to linking tab and uncheck lead in and lead outs. And then go ahead and hit OK and check again. Let's go simulate. Yes, so now it's just straight plunging into the material, cutting a little bit out of a time, and it's cutting the nominal value. Look at it from the top. And yes, it did take everything within the boundary, and we have a 1mm end mill, so yes, we're good. Okay. So now that we've got all the inlays set up, now we need to decide, do we want to go ahead and cut the radius, or do we want to cut the contour? Now, I think it's smart to always leave the fret slots last. And that's why I said either cut the contour or the radius next, because the fret slots, the end mills that have that tiny of a diameter have a very, very small effective flute length. And so we want to give it as little material to cut through as possible. So we don't want to have our stock, for example, being all the way up here and having to cut through all that material as well. So I think it's smart to always cut the radius and the contour before the frets. So I also think it's smart to go ahead and cut the contour of your fretboard next. Now this also kind of depends on how you plan on work holding this fretboard. I personally think it's really smart to just use the blue tape and super glue method with fretboards because you get basically unlimited, at least for this fretboard, basically unlimited holding power, but you get full access to the side of the contour of the fretboard. You don't have to worry about clamps or anything like that. So I'm going to go ahead and cut the contour first and then cut the radius, but you could do it the other way around, especially if you're not using the tape and super glue method. Just be mindful that you may run into cam errors by running a parallel path while there is still stock there available on the sides. So let me go ahead and show you. So we're going to cut a simple 2D contour, and we're going to change our bit to whatever size bit we'd like to use. Now, I would say that we want to use the same bit for both the contour and the radius, and I'll show you that in a little bit. So we're going to do a 1/4 inch flat end mill. And let's select our geometry. So I want it to cut all the way around the perimeter. And then we can go heights. We want to go down to the selected contours. Yes. And in this case, we do want it to go from stock top. No, we don't. We want it to go from model top plus 20 thou. And then in passes, we want to, depending on the capability of your machine, you may want to do multiple depths or not. I'm certainly going to, so I'm going to say multiple depths of 0.0625 is roughly 1.5 millimeters. And then I think that'll be good. So let's go ahead and hit OK. Yes. Now you'll notice that you are left with some of this material on the side. That's okay. Once you cut this, you can go ahead and pull that material off because that will just be waste. Now, if you did want to just mill the entire inside in, you could totally do that with like a 2D adaptive or 2D pocket and just mill everything off that's not your fretboard. Some people might call that a waste of wood, but I don't really know. It depends on the stock you're cutting it from. You know, if you're cutting it from a much larger piece, then yes, you definitely don't want to do that. If you have a piece of stock that is really close to the size of your fretboard, maybe it actually is the right way to do it. We'll just go ahead and leave it with the contour for now. And then assuming that once we cut that contour, we're going to pull this stock off and just break it free. And so all we're left with is the fretboard right here. And I think that's going to be good. You know, let's actually leave a little bit of stock to leave. We'll do the same thing we did in the other one. Let's dial in the size. So stock to leave, we'll leave 10 thou radial and 0 axial. Just going to leave just a little bit of material, and then we can duplicate this. Actually, let's just go ahead and straight duplicate it rather than create a new derived operation. And then edit it, take off multiple depths, and then stock to leave, you know, we could adjust it, let's say to nominal if we need to. That way we can come back in and basically do a finishing pass, but we can also adjust the size if we're finding that it's not quite right. So let's go ahead and simulate that real quick. We'll simulate both at the same time. Okay, so we're cutting around the contour, but leaving a little bit of material left over. Kind of hard to see. Let me pause it and look at it from the top. Okay, yep, you can see that little bit of material right there. And then we're coming back in with a separate operation to come in and cut at full depth and clean up that whole contour and remove that extra stock to leave. So that way you get a nice surface finish around the entire outside. All right, so now that that's done, let's go ahead and cut the radius of our fretboard. So we can actually use the same end mill. We can, if you've watched any of my other videos, you know that I actually really like using flat end mills to do what effectively a ball nose end mill would normally do, provided the geometry supports it. So I'm actually going to go ahead and do a 3D parallel. And I'm going to use the same 1/4 inch flat end mill. And what we're going to do for the machining boundary is selection. We're going to select our fretboard right there. And then what we can do is go heights. We're going to go to model bottom. Actually, Yeah, that's fine. We can say model bottom. Well, we might have to change that in a little bit. And we're going to go from model top plus 20 thou as our top height, because we still have that material there. And let's go ahead and, well, let's change our step over. Let's make the step over really small. So like a 10 thou step over, hit OK. Let's see what it's going to do. Okay, it's actually looking pretty good, but I suspect that we might get a little lip right here, as you can see. So I want to check something really quick and hit edit, come over to our geometry tab, tool selection. Let's see what happens if I say, so right now it's center on boundary. Let's check outside boundary and see what happens. Okay. Because we've actually already removed all this stock, like for right here, you could see that it's actually just looping off, but it's detecting these weird areas where it wants to dip down. So what you could do is, if it just depends if you want it to pass way off the outside, it might not be that important. You can just come in here and say center on boundary, and let's simulate that real quick and see what that's going to look like. I am just a little worried that if we put the center of the tool right here, that you'll see what I mean. Here, let's just go and simulate it and I'll show you what I mean. Okay. Speed it up. So right now we're carving with the edge of the flat end mill, and then it comes flush. Okay, right here, I suspect, look at it from that angle, I suspect that we're not going to get it far enough off the fretboard. Yeah, see that? It dipped up and it didn't actually cut all the way to the edge. So we need our tool to be able to go off of the edge of the fretboard entirely. So we need to have outside the boundary. That means it can go out here. And if we hit OK right now, it's like we showed you before, it's going to try to cut down. So we need to either limit it, we need to limit it in some way. So let's go ahead and try just using avoid touch surfaces. And so we can say avoid that surface, and that surface. So it's not registering those in the surfaces that it needs to cut. And let's see if that solves it. Hit OK. And it looks like yes. Okay, so let's resimulate this, and just to double check. Okay, it's going to come down. It's going to make a few passes here on these outer parts. Let's get past that real quick. Okay, and let's check it right here. Yes, it does go all the way off the edge of the fretboard. Let's look at it from this angle right here if we can. And yes, the bit is going all the way off the edge, so we are making full contact. That's great. Go ahead and hit OK. And I just want to double check. Do we have any stock to leave set up? No, we don't. Okay, perfect. Because we want to cut down to the final dimension here. And keep in mind, what this is going to be doing is it is going to be milling off all of the top of your inlays. So if you have a really hard material in there, let's say like stainless steel or aluminum or copper or like a hard maple or some dissimilar material from the fretboard you're using, you might want to adjust your feeds and speeds for that material more so than your fretboard, because you're going to be sanding that fretboard anyway, but you don't want to break your bit or anything like that if you're using some kind of metal or something in there. So before we move on to the fret slots, let's go ahead and simulate everything that we've done so far so we get an idea of where we're at, and then we'll take care of the fret slots, which is the most tricky part of this entire process. So I'm going to select all of these, right click, simulate, and let's unhide transparency. And let's go ahead and let's change this from tool to comparison, so it will show us when we've hit the actual material. It'll show us our model in green. So let's go ahead and hit play. The first thing that it's going to do, it's going to face off the material in 2 layers. This is layer number 1, layer number 2. Okay, and then it's going to come in with a 1mm end mill, so we will have done a tool change at that point, and it's going to mill most of the dot inlays out of it, and then it zoomed past that really quickly, but let me pull that back. Okay, it's going to mill most of that, and then it's going to come in and clean up those sidewalls, so you can see now we're full contact, but we still have a little material on top. And right now it's milling out most of that ring inlay. And then we do another tool change where it comes to a 1/4 of an inch end mill and it cuts the contour. All the way down in multiple depths. And then once it's finished with that depth, it comes down at full depth and cleans up the entire side of the fretboard. That way we get a nice surface finish around the whole thing, and that also allows us to dial that in if we need to. Okay, speed it up a little bit. And now we're coming into the longest part of the operation, which is we're going to be milling off the radius of the fretboard. So it's doing this little part first. Now we did get a little bit of a little lip here. I don't think that's a big problem. If we needed to, we could probably add a little bit to that. I don't think it's a big deal though. That can just flake off. It's so thin. That's probably like 1/1000th of an inch thick. Okay, so let's speed this up. And we are doing a very long toolpath of parallel passes with a flat end mill, milling off all the tops of the inlays and establishing the fretboard radius. Okay, and if I hide my model, there we go. This is where we're actually at. You can see these little blue lines here. Those are the fret slots that we haven't cut yet. Okay. So we're 95% of the way there. Now we just need to cut our fret slots. We've got the entire fretboard contour, the inlays, and the radius cut. So let's go ahead and move on to the fret slots. Now, there's 2 different ways to do the fret slots because it depends on what type of fret slot you have. So if you have a straight and flat fret slot bottom, then you can do it one way. Or if you have a curved fret slot bottom, so it follows the contour of the radius, then you might do it a different way. So I'm going to show you both, and we're going to start with the flat because that's what I have in the model right now, and then we'll switch over. So if you have a flat fret slot bottom, you can actually use the geometry. If you've modeled the fret slots, you can use the geometry. So let's go ahead and do a 2D contour because all we really care about is one side of this because we're going to be using a bit already of the correct size. So let's go to select our tool, and I have a 0.023 inch end mill, which is basically 0.6mm end mill. Hit OK. And then under our geometry, we can select all of these contours. Might take me a second, sorry. Okay, phew, finally we're there. I always hate selecting every fret, it's annoying. Okay, so we can use a 2D contour, and we'll go down bottom height to selected contours. And now we can just go from top height. We'll go from model top, but we don't add in the extra 20 thou because we just removed that in the parallel toolpath. And then we need to do it in multiple depths because this is a very tiny and fragile little end mill. And I will go more into feeds and speeds later. There's a reason why I haven't talked about it yet, but we'll talk about that in a minute. And then in the roughing step down, I would recommend doing like 5 thou. Like something really tiny, because if you do this right, you can actually, you can protect your end mill, but you can actually cut this fairly quickly. So even though that seems super tiny, I definitely wouldn't try to plunge the entire thing all the way down. Save yourself the money, spend a little bit of extra time cutting the fretboard or the fret slots, and cut a really small depth of cut. And then we don't need any finishing passes. We don't need any step overs or anything like that. We should be good to go with pretty much just this. So let's check. Okay. So it's going to cut straight lines all the way across, starting at the top of the model and working its way down. So let's simulate that real quick. Okay. Where is it starting? Okay, I think we need to do the same thing we did before, which is preserve order. So let's go back to our contour and hit edit. And we will go both ways. So that way it's cutting in both directions. It's not picking up after every time. And we'll say preserve order. So it cuts them in the order that we selected these. Okay, and let's hit simulate. Now it should be starting over here now. Yes. Okay, and it's going to cut them in flat paths all the way down. And then move on to the next one. Now something you might want to keep in mind is you may want the tool to go a little bit past the barrier. Let's see. Yeah, you see how it kind of stops right at the edge there? You might get a little bit of a cusp, so we might have to do some kind of like tangential extension. So let me see if we can do that real quick. So edit. And in our geometry, we have tangential extension. What that does is it extends the toolpath off of the contour by the distance that you tell it to. So that way we can make sure that it clears the entire slot before re-entering. So I can say like an extra 30 thou, or let's go at least 1 bit diameter off. Let's do, you know what, let's just do a 1/16 of an inch off. That's a lot, but it's okay. And here we go. Let's try that. So you can see now it's actually extended the toolpath off of the fretboard by a 1/16 of an inch. So that way when we resimulate, the bit is both entering. Speed this up and look at it from the side. Sorry, there we go. You can see that it's going to come all the way out to here off of the fretboard. Yeah, let's speed this up a little bit, move it down the path a little. There you go. You can see that it actually stepped all the way out and we're good to go. So if you're doing flat fret slot bottoms and you've modeled the slots, that's really all there is to it. It's very simple. Where it gets really tricky is when you start doing curved fret slots, because a simple contour operation doesn't work very well for that. And you end up having a little spot in the bottom, especially if you're doing blind curved fret slots. For example, you might have a little spot in the bottom that's actually not quite the right depth. So what I recommend doing when we do curved fret slots is actually coming back to your design workspace and suppressing those slots if you have them modeled. So let's say like, I think it's this one right here. If I suppress those, basically just get rid of them. And then what you can do is you can actually project in your fret lines from your sketch to the surface of the fretboard. And then you can use that as your cutting tool. Now, you might not have to suppress the feature. I find that it's typically just helpful to do so. But if you don't know how to project your sketch lines to that surface, check out my mastering fretboard video, because I do show that at the very end of the video in detail. I'll leave a link to the top here. But now we can come back to the manufacturing and we can do, let's regenerate all these real quick. Only the last one should throw an error because those slots aren't there anymore. So I'm going to go ahead and actually suppress that one, so it gets it out of my hair. And what we're going to want to do is we're going to want to do a 2D trace. And we want to come in here and show our sketches. Now I have a fret slot project for cam already selected. And so these are curved lines that match our fret slots on the fretboard surface, and we're going to use that as our selection. So we want to come in with the same 0.023 end mill. In geometry, we want to select each one of these. In fact, I'm going to hide the body, save you guys the time of watching me select all this stuff. If it will let me. Okay, maybe not. We'll just select all these real quick. A lot easier than having to zoom in and out, isn't it? Okay, we're going to cut all of these. And then let's bring our body back. And then because this is technically a 3D toolpath, even though it's in the 2D section, there is no bottom height. It's just going to cut based off of the constraints we give it in the passes tab. So the way a trace toolpath works is it starts at the line and it traces that line at the center of the bit. And then you tell it how deep you want it to go by how many step downs essentially you want to give it. So this is called axial offset. So axial offset, you give a manual depth. So let's actually hit OK and close this out real quick. And then we're going to measure our fret depth. So I'm actually going to unsuppress this for a second. And we're just going to measure that right there. So basically 0.07 inches. So let's go ahead and resuppress that. Come back to manufacture. Open this up and we want to give it an axial offset of 0.07 inches. Negative 0.07, I believe. And let's check that real quick. Yes, okay, so it is cutting that, but we need to make a couple changes because right now it's going to cut it at full depth. So come back and hit edit. And we want to say multiple depths. Now I'm going to give it the same rule that I did with the 1mm end mill. I'm going to say 0.005, so 0.005 of an inch. And then here you can say how many step downs do you want, right? This is kind of different than the normal one because the normal one, it just kind of evenly divides it by that. But in this case, even if I select 0.005, it's still only going to do one cut. So I then need to tell it how many. So what we actually got to do is bring out the calculator. And we need to take 0.07 divided by 0.005. And that's 14. So that would be 14 step downs. So let's go back to passes and say 14 step downs. Hit OK. And let's hide our model so we can see this maybe a little bit better. There you go. So now you can see we have all these little step downs. That should be good, but let's see if we can add a extension to that. I don't know if we can. Doesn't look like it. Yes, we have a pass extension right here. I'm going to do the same thing. I'm going to go 0.0625 off of the fretboard. There we go. So now you can see it's going to extend off the fretboard a little bit. And you can see that our actual fret slots are curved. So that way we're actually just cutting them that way. Let's go ahead and simulate this. Let's hide our sketches here. And let's hit play. Okay, so it looks like it's starting on this end. Now that's coming up pretty high, and it looks like it's ordering by depth again. We might need to check about preserve order. So let's go ahead and hit close, edit. And do we have a preserve order? Yes, we do, right here. Hit OK. Resimulate. Hit play. That didn't do it. Okay, hold on. Edit. Right now it says ordered by depth. So it's going to cut one depth, then move to the next slot, cut that depth. We want to uncheck that, hit OK. And now it should significantly, in theory, reduce the amount of movements afterwards. So it should cut everything all at once. Yes. Now it's cutting the entire slot all at once. Okay, let's speed this up. And let's turn on transparency on our stock. Turn on our body so we can see it. And yes, as you can see, we've hit the walls on both sides, and it looks like we are good. Okay, so that is going to be exactly the same process whether you have blind fret slots or not. Whether they come off the edge of the fretboard or stay on the inside, you would still use the same tool path. You would project your sketch lines up to the surface and use a 2D trace with an axial offset to go ahead and cut those fret slots. Okay, so all the simulation is done. We've now cut everything on the fretboard, but I've neglected, or rather avoided, talking about feeds and speeds. So why is that? Now, feeds and speeds is an interesting topic because we're dealing with some really tiny end mills here, and we have to get that right to not break those end mills. However, feeds and speeds are entirely dependent on what your particular machine is capable of. And so what I recommend in this video might not be the right answer for you on your machine. And I don't necessarily want to put out bad information, but I will go ahead and talk about what is important to keep in mind when you're programming the feeds and speeds for these tiny end mills. And that is chip load. Chip load is king, or feed per tooth rather, is king when it comes to these little end mills. So let me show you the way I thought about it and how I was able to cut my very first fretboard with no broken end mills and perfect fret slots. So if we close this out and we go into that final trace operation, let's hit edit and let's go to the feeds and speeds area. Now, I always program all of my toolpaths to the bottom speed of my router. Now I use a DeWalt trim router, and the bottom speed is 16,000 RPM. Now, if you have like a VFD spindle, you basically have free range over your RPM, so that's probably not that important to you. But what is important is the feed per tooth, right? So if we are dealing with a really tiny little end mill, I generally, now this isn't always a hard rule, but I generally program my feed per tooth to roughly 5% of the tool diameter. So if I go to calculator, 0.023 end mil and times 0.05 leaves me with just over 1 thou shaving per revolution of the end mill. So if I just round that down to 1 thou feed per tooth, that means for every revolution of the tool, I'm going to take 1/1000th of an inch off. Now my cutting feed rate, because right now I'm using a 2-flute 23 thou flat end mill, my cutting feed rate is 32 inches per minute. Now that's pretty slow, and we're also taking a pretty shallow depth of cut if you remember from the tool path of 5/1000ths of an inch. So I'm taking a 5 thou shaving at 5/1000ths of an inch depth. That seems to be a pretty good value for me. However, what I did when I cut my fretboard for Mare was I knew that that tool path was going to be sluggishly slow and that these end mills are very fragile. So I went out and bought a 4-flute end mill, which has a much more, a larger diameter inner web, which means that it's going to be less susceptible to breaking. And because it has 4 flutes, that doubles my feed rate. So I was able to run, so let me go back to my tool here, and let's change this tool to you pay attention over here. Right now it's 32 inches per minute. If I change this to a 4-flute end mill, hit accept, select, and I go back to 1 thou feed per tooth and 16,000 RPM, you know, it just went from 32 to 64 inches per minute. So if you double your flute count, you double your feed rate for the same feed per tooth. So I really recommend, especially for like these little fret slotting end mills, to find a 4-flute proper end mill because you can run them much faster. They're less susceptible to breaking, although they still are. They're still very tiny, and running them at a 1 thou feed per tooth. And then it's just basically a matter of what RPM and what feed rate do you want to run it at. So if I want to run this at 120 inches per minute and 0.001 feet per tooth, I might have to adjust my spindle speed. So let's say 27,000, which is the top range of my spindle. And I could say 0.001 feet per tooth. Well, then I could cut it at 108 inches per minute. And it would still be taking the same amount of shavings or the same tool pressure. I'd just be moving my machine much faster. So what I always do is I always program it to 16,000. And then on these tiny end mills, it's roughly 5% of the tool diameter, which in this case is roughly 1,000 feet per tooth, which left me with on a 4-flute end mill, left me 64 inches per minute. And I'm perfectly happy with that. And that might even be kind of blazingly fast for such a tiny little end mill. And then if I need to, and I feel like the end mill is at risk of breaking or hogging out too much material, I can always just put my thumb on my router and speed it up. And by speeding it up, so let's say I move it to 18,000 and 62 or 64 inches per minute, I've effectively reduced my feed per tooth. I hope that makes sense. So basically I start with my normal value of 16,000 RPM, and at 4 flutes, 64 inches per minute, 1,000 feet per tooth. And if I feel like it's taking too much off or too hard on the tool, I just speed up my RPMs because my feed rate hasn't changed. It just reduces my feed per tooth and takes it easier on the tool. So that's what I recommend for both the 1mm tool and the 0.6mm tool or 0.023 in Imperial, is focusing on the feed per tooth. Do like a 1,000 and then find the right RPM and cutting feed rate that you feel is appropriate for your machine. So there we go. Now you have the basic techniques for how to program the cam for fretboards in Fusion 360. Now, fretboards are arguably the simplest part of cam for guitars, but like I mentioned in the video, you kind of get to choose your own adventure on the order in which you'd like to structure the toolpaths. And also you have to take a bit of caution on protecting those tiny and very expensive little end mills. So I hope this information was helpful, but by all means, if you guys have better methods or you've experienced a better way of doing this, let me know down in the comments. I'm always eager to learn new techniques. So that being said, if you guys would like to support the channel or would like to download any models featured in any of my videos, you can find me on patreon.com. It really goes a long way to helping me produce these videos long term. And if you want to ask me a question or chat with me in general, or join a pretty awesome community of hobbyists, designers, engineers, and luthiers from all over the world, you can join our Discord server. Links will be in the description below. But that's it for this week. I will see you guys in the next video. Happy 4th of July to my American friends, and this is Austin signing out.